Hello, how's everyone doing? This is Simrat Hanspal, technical evangelist and AI engineer at Hasura. Have you guys ever asked your folks for books recommendation and realized they have recommended books that they've read and liked and not what you may like? Ever wondered how amazing it would be to have a system that can recommend books to you based on your mood? Well, I built one for you. And today I'm going to talk to you about how I built a smart book recommendation with pgvector on Neon and Hasura in very little time. So let's get started. What are the ingredients? Well, the ingredients are large language model, a collection of books data, and most importantly, you need RAG. RAG what? Large language models are great, but they're frozen in time and cannot solve tasks on data it hasn't seen before. One of the ways to expose the unseen data to large language model is by providing the context related to the question. This helps the LLM to generate more accurate and grounded answers. In this case, recommend books that actually exist and not make up one. This powerful technique is called retrieval augmented generation, or RAG in short. So you see, we need to build a RAG pipeline for our books recommendation use case. We also need to make sure that our RAG pipeline is production ready. Building data API already takes up a lot of our time. Building dynamic data API, it takes the challenges to next level. So let me show you how I built this really cool application in no time. Let's get started. To get started, first we'll have to head over to the Hasura console and create our database. And I'm not going to be doing this because I already have a Neon database available, but in case you don't have one and you're just getting started, you can always scroll down and click this yellow button to get yourself a free cloud Postgres database. I have this already, so I'm not going to do that. Next, we will move to Neon's dashboard and collect this connection string. We're going to be using this for a bunch of stuff because we're going to be running few queries on Postgres terminal. Right. Another prerequisite is Hasura Notebook. Hasura Notebooks are cloud-hosted notebooks that not only let you experiment quickly, but it also enables you to create dev endpoints so that you can prototype really fast with Hasura. It enables you to iterate fast. We also have a bunch of pre-built project templates so that you can play around with them. The way you get started is you use Hasura CLI to execute this notebook create command. Once you do that, you are provided with a URL. You can head to that URL, and the first thing that you will see is a dashboard like this. You can launch the notebook, start, stop, restart your endpoints that you're serving from your notebooks. And let's get started with the data part first. Right. So like I mentioned before, we will need the connection string to use the PSQL. The first thing that we will have to do in order for us to use the pgvector is to enable the vector extension. The next thing that you will see is that we have two tables. One for the books, which has all of the data related to the books, and the second one is for the embeddings. This is where we are storing our vector embedding. Now, you can use any embedding model of your choice, but I have used OpenAI's ADA embedding, which is of size 1536. You will also notice that we have two functions. Now, this is required because vector is a new data type and it is not supported on Hasura at the moment. So we have to build a workaround for that. And the way we do that is we treat the vectors as text strings and Hasura. So while calling any of the Hasura APIs, these are strings, but when you actually execute it at the level of DB, we typecast it. So the first function that we have is for the insertion needs, where we take the embeddings and we insert it into the table. And the second function that we have, sorry about that. And the second function that we have is for the retrieval part, where given an embedding, we look up similar or related results and we return the best results. Right. So we are ready with our schema. And so you can almost say that we are ready to get started with loading the data. Right. And I would say we are ready to load the data, but we are not ready to do the multiple or duplicate effort. So if you remember, we have the books table and also the books embedding table. I don't want to write to two tables twice. It's some amount of effort. So I want to reduce that. And what we're going to do is use Hasura's capability of events trigger to optimize this. And what we're going to do here is that as and when a new record or a new book gets added into the books table, I'm going to auto vectorize that and add that to my books embedding. So let me take you to this notebook, which has all of the endpoints. First thing first, the way you set up endpoints is by defining this comment. So here you're defined that this is an endpoint with the name handle event. And what we are doing in this event is that whenever a request comes in, we are processing it with the business logic, which in this case is to take the description, get the embedding out of it, and call the first function that I showed you, which does the insertion or the writes into the table. Good. So now if you move onto the Hasura console, you'll see that I have two tables, the books and the books embedding. They're empty. The first thing that we're going to do here is set up an event trigger. I'm not going to do that again because it's already set up, but I'll walk you guys through it. So define event trigger name, what's the source, books, schema, and where is it going. So this request is going to be handled by this webhook, and this is nothing but the URL of my notebook. I just had to suffix it with invoke, and then it's the endpoint that I defined in my notebook, which is this, and the URL is this part. It's just the same, nothing else. And we will also have to define the authorization because this endpoint is coming from an authorized notebook. Great. So once our event trigger is set up, you saw that our data is not, there's no data in the system yet. So we have some insert queries. We will execute this. It looks like it has executed. We will head back to our data and you'll see that not only did we get the books, but we also got the vectorized data. Amazing. So now that we are ready with our data, now we can head to building a recommendation system. So the way we are building this recommendation system is by using a capability of context retrieval and augmenting that context to the LLM, as I told you. So in this case, we are taking the user query that is coming in, generating and embedding out of that, and fetching relevant books that becomes the context to our LLM. And our LLM is assigned a very specific task, very specific personality, and a very specific task to answer the user's question with a list of books. So it's got to recommend a book and also explain why. What additionally we are doing is we are taking our results and formatting that for our prompt. Now, if we go back to our actions, I have already defined this business logic here. Defined it as a recommendation query, which takes a string input and returns a string output. Again, I've defined the webhook where this business logic resides, which is nothing but the URL of my notebook and also the endpoint that I defined for that business logic, which is this. What additionally I've done here is set a little really extremely large, but you can set something more reasonable as a timeout because LLMs are slow in processing and generating responses. So it might be good to have a decent timeout set for your application. So now let's head over to API where we have all of this information, and I'm going to ask for a recommendation. I'm going to say that, let's say I am traveling to Singapore. Sorry about that. Singapore next week. I want a thriller read for my travel. Let's see. There you go. So we have some recommendation. It says that for thrilling read to take on your travel, it recommends a book, and it's a perfect read to keep you on the edge while you explore the city. Amazing. That sounds like a really good recommendation. So I think we're good to go on a vacation. So that's it from me. Thank you. Thanks everyone.